Recently, a fascinating revelation has caught the attention of both scientists and space enthusiasts. Bill, a prominent science communicator, made headlines when he revealed that Voyager 1 had detected 300 enormous objects in the depths of space. This discovery has sparked intense curiosity and prompted significant questions. What are these objects, and where do they originate? Join us as we explore the mysteries behind the astonishing findings reported by Voyager's first mission. For nearly 5 decades, the Voyager missions have delivered some of the earliest and most remarkable glimpses into the wandering bodies of our solar system. Surprisingly, these missions were never meant to last for such an extended period. In the 1970s, Michael Minovich proposed an innovative concept that spacecraft could utilize a planet's velocity to propel themselves deeper into the solar system. Initially, the Voyager mission was designed to last only 5 years, but it has far surpassed those expectations. Launched within weeks of each other in the summer of 1977, Voyager 1 and Voyager 2 were tasked with exploring Jupiter and Saturn. They achieved this by providing in-depth studies of these giant planets. However, their journey didn't end there. In 1986, Voyager 2 made history by performing the first close-up observations of Uranus, followed by a similar mission to Neptune in 1989. This incredible flyby of 4 planets earned the mission the name Voyager Grand Tour. Instead of concluding, the resilient spacecraft turned their sights on a more daring goal, exploring the vast expanse of deep space. Now, 45 years later, both Voyager 1 and Voyager 2 continue their journey, gathering vital scientific data from far-reaching regions of the cosmos. In 2013, NASA made an extraordinary announcement. Voyager 1 had officially crossed into interstellar space, the area between stars, beyond the reach of the Sun's magnetic field and particle influence. It was akin to leaving the crowded confines of the solar system and stepping into a tranquil wilderness of stars. This journey continued in 2018 when Voyager 2 also entered this vast space. Located 17.7 billion kilometers from the Sun. Amazingly, Voyager 1 and Voyager 2 remain the only spacecraft to have ventured into interstellar space, where they study how the interstellar medium interacts with the solar wind emitted by our Sun. These groundbreaking missions have become our primary source of information about the heliosphere, a protective bubble that surrounds and shields our solar system. The heliosphere, influenced and shaped by solar wind, a constant stream of charged particles from the Sun, acts as a barrier, protecting our solar system. Both Voyager 1 and Voyager 2 have served as our cosmic messengers, relaying essential data about the celestial shields that protect us. All this information converges at the heliopause, the outermost boundary of our solar system, marking the transition from solar wind to the vast reaches of interstellar space. NASA's Voyager spacecraft have provided us with a deeper understanding of interstellar space. One remarkable discovery has been the observation of cosmic rays, mysterious, high-energy particles that are significantly more intense beyond the heliopause than within the protective limits of the heliosphere. It's comparable to the calm of a peaceful backyard, contrasted with the intense energy of a bustling street. But the story doesn't end there. NASA didn't stop with just Voyager's findings. By integrating data from other missions with Voyager's observations, scientists have been able to create a more complete picture of how the Sun interacts with the surrounding interstellar space. Through this grand cosmic adventure, scientists made another unexpected discovery in 2023. Voyager 1 detected a faint, low-humming sound that corresponded to vibrations in a small amount of gas drifting through interstellar space. Nicola Fox, head of NASA's Heliophysics Division, emphasized how the Voyager missions have provided invaluable knowledge over the past 46 years, revolutionizing our understanding of the Sun in ways no other spacecraft has managed to do before. This incredible voyage through space is even more impressive considering the power limitations of the Voyager spacecraft. Both spacecrafts are powered by a plutonium-based system, but as the plutonium decays, it generates less heat, gradually depleting the spacecraft's energy. To cope with this challenge, NASA has been forced to make tough decisions, shutting down non-essential systems and even turning off heaters designed to keep instruments warm in the freezing void of space. Despite these obstacles, all 5 essential instruments on both spacecraft have remained operational since 2019, defying expectations. Scientists are still baffled as to how the Voyagers continue to function in such extreme cold conditions, where other spacecraft would freeze. This ongoing mystery adds to the awe and legacy of these remarkable space pioneers, whose journeys continue to surprise astronomers and expand our understanding of the farthest reaches of our solar system. The heliopause, which marks the boundary between the Sun's influence and interstellar space, is not a fixed point but instead shifts, sometimes forming unusual angles. This discovery has left scientists both intrigued and perplexed. The idea that the heliopause might change shape is not entirely new. Over the last decade, researchers have used data from Voyager 1, Voyager 2, and NASA's Interstellar Boundary Explorer, IBEX, satellite to observe its tendency to shift. These spacecraft have provided crucial direct measurements of these cosmic boundaries, even if they can only capture snapshots of specific locations at given times. Dr. Eric J. Sarin, a space physicist from Preston University, expressed his excitement in an email to Vice, noting that the IBEX satellite has been supplying valuable data that's helping scientists redefine their predictions about the future movements of the heliopause. What makes this even more fascinating is that recent studies have challenged earlier assumptions. In 2014, IBEX detected an unusually brightening of energetic particles, hinting at irregularities in the heliosphere. However, these anomalies didn't fit existing models, almost like an unexpected plot twist in the story. Researchers also observed a significant shift in the heliopause position over a short period, which may explain why Voyager 1 crossed into interstellar space in 2012, followed by Voyager 2 in 2018. Despite the size gap between these events, these surprising findings are not only puzzling but contradict what scientists had believed about the heliosphere. In a recent article in Nature Astronomy, researchers referred to these discrepancies as the entry speaking, suggesting that they may prompt further debate and investigations within the scientific community. The search for answers continues. NASA's upcoming Interstellar Mapping and Acceleration Probe, IMAP, scheduled for launch in 2025, is expected to reveal even more secrets about the outermost edges of our solar system. Meanwhile, the mysteries persist. In May 2023, Voyager 1 experienced an unusual event. Its Altitude Articulation and Control System, AACS, which manages the direction of its high-gain antenna, began to send confusing data. Instead of the usual health updates and study reports, it seemed as though Voyager 1 was struggling to communicate, almost as if it were experiencing an electronic glitch, a kind of communication confusion. From Earth's perspective, it appeared as though Voyager 1 was encountering electronic difficulties. The data it sent back indicated anomalies that seemed random and incoherent, as NASA described it. Despite these strange reports, Voyager 1 itself appeared to be functioning normally. Its radio signal remained strong and stable, indicating that the antenna was still pointing toward Earth, contrary to what the AACS was suggesting. Adding to the mystery, Voyager 1's scientific instruments continued to operate smoothly, unaware of the AACS malfunction. Even the spacecraft's fail-safe production system, designed to place it in safe mode during malfunctions, was not triggered. Fortunately, NASA quickly identified the problem. The AACS had been using an inactive computer for an extended period. The solution was simple. They sent a command to switch to a working computer for data transmission. However, the cause of the AACS's unusual behavior remains unclear. NASA speculates that an incorrect command from another onboard computer might have caused the issue. While this event didn't endanger Voyager 1, NASA continues to investigate the situation to prevent similar issues in the future. Voyager 1 has now been exploring interstellar space for over a decade, outside the protective magnetic field of the Sun. This field, much like Earth's magnetic shield, protects spacecraft from cosmic rays and radiation, acting like a cosmic suit of armor. However, like all technology, Voyager 1's onboard computers face challenges from the high-energy particles in space. Occasionally, these energetic particles can interact with the spacecraft's computer chips, causing minor memory errors that accumulate over time. Susan Dodd, project manager for both Voyager 1 and Voyager 2, offered a broader perspective on these challenges. She explained that such anomalies are to be expected at this stage of the mission, given that these spacecraft have been on an extraordinary journey for nearly 5 decades. far exceeding their original mission timeline. Now navigating the uncharted territory of interstellar space, where radiation levels are high, the Voyagers face challenges unlike anything any other spacecraft has encountered. Nearly 50 years have passed since Voyager 1 and Voyager 2 began their historic missions, covering immense distances and exploring the unknown. Despite their 1970s-era computer systems, which had only 70 kilobytes of memory, yes, just 70 kilobytes, NASA has managed to keep these far-flung explorers operational. Imagine the effort involved in sending software updates across vast cosmic distances. Ensuring the ongoing operation of the Voyager spacecraft is akin to providing cosmic tech support in the vast emptiness of space, billions of miles from Earth. These legendary spacecraft continue to cross major milestones, offering profound insights into the mysteries of our solar system. Let's take a moment to appreciate these trailblazing pioneers, Voyager 1 and Voyager 2, as they continue drifting endlessly among the stars. Each spacecraft is roughly the size of a small car, representing the technological spirit of the 1970s. Despite their outdated computer systems, which are far less powerful than today's digital watches, and their analog TV cameras that now seem primitive compared to modern ones, the Voyagers have left an unforgettable mark on every celestial body they've encountered. Thanks to these spacecraft, we've uncovered amazing details about the planets they've studied. For example, Jupiter was revealed to be not just a calm giant but a world of extremes, with hundreds of fierce hurricanes, a glowing aurora at its north pole, and intricate rings. Saturn, once thought to have only a few simple rings, was shown to have thousands of delicate rings with bright structures previously considered impossible. Even more astonishing was the discovery of active volcanoes on Jupiter's moon Io and nitrogen geysers on Neptune's moon Triton, with temperatures near absolute zero. Perhaps the most exciting revelation, however, was the discovery that two of Jupiter's moons, Europa and Saturn's moon Enceladus, are believed to harbor vast salty oceans beneath their icy crusts. Oceans that might support life, making them prime targets for future exploration. One of the most poetic moments in Voyager's history came in the early 1990s when, at the suggestion of Carl Sagan, one of the mission's key visionaries, the spacecraft took a final look back at our solar system. It captured the iconic image known as the pale blue, showing Earth from 100,000 times farther away than any human had ever seen it. This humbling image served as a reminder of our place in the vast universe. In 2012, Voyager 1 made history by crossing into the interstellar medium. Over 11 billion miles from the Sun, Voyager 2 followed suit in 2018. These spacecraft are now so far away that it takes 22.5 hours for radio signals from Voyager 1 to reach Earth, and nearly 19 hours for Voyager 2. They continue to move, getting further away by 3 to 4 light seconds every day. NASA's Deep Space Network, with tracking stations around the world, ensures continued communication with these distant explorers, even as the Earth spins. As the Voyagers journey further into interstellar space, their signals have become faint whispers amidst Earth's noisy backdrop of radio waves and technology. Nonetheless, they continue to send back invaluable data, proving the resilience and brilliance of the mission. The Voyager mission itself was born from a stroke of luck. Initially, scientist Michael Minovich discovered that spacecraft could gain speed by using gravitational assists from planets. Later, Gary Flandreau demonstrated that a rare alignment of the outer planets in the late 1970s and early 1980s would allow spacecraft to reach Neptune in just 12 years rather than 30. NASA seized this once-in-a-lifetime opportunity, though it was constrained by budget limitations, and designed a scaled-back version of the original Outer Solar System Grand Tour. Nearly 50 years later, Voyager 1 and Voyager 2 remain humanity's most distant emissaries, unlocking the secrets of interstellar space. Their legacy will endure for generations, reminding us of the endless curiosity and perseverance that drive us to explore the unknown.